All right, so this is algebra in chapter 9, and we'll be talking about radicals in chapter 9, and specifically in 9.1, specific properties of radicals. So here are some key terms. You need to know what a radical is, first of all. So that symbol right there is a radical. You might know it as a square root. Sometimes it's a square root, but it's always a radical. And then a radical expression is just any expression that contains a radical. I said sometimes this symbol right here is a radical because it just depends on the root that you're taking. So a radical expression could be written like this. This is the nth root of whatever you'd be taking the root of. So the index is the root that you're taking. If there's nothing written like this, if I just had the radical and I made it like this means that you're taking the square root of 25, or really the implied index is 2. When I just wrote the square root of 25, this is also the square root of 25. Sometimes you could take other roots. If I had something like this is the cube root of 8. In other words, you'd be looking for what number do you cube or raise to the third power that would equal 8. But this is the index. It's also the root that you're taking. And then the radicand is what's underneath the radical. So on this example here, 25 is the radicand. 8 is the radicand. It's whatever's underneath the radical. Sometimes you could have like a variable expression as well. And then what we'll concentrate on in 9.1 is putting radicals into simplest form. And a radical is in simplest form if the following conditions are met. Well, right now I only have one condition. There's no perfect square factors under the radical. Okay, there's going to be a couple of others that we'll cover in the next couple of days, but right now we'll concentrate on getting any perfect square factors out of the radical. And then since we'll be simplifying radicals by looking for perfect square factors, you need to know the perfect squares. So the perfect squares are just square numbers, or they're also integer values squared. Technically, 1 is a perfect square because it's 1 squared, but I'm going to cross it out because it actually won't help you simplify a radical. The next perfect square is 4, and then the reason why 4 is a perfect square, it's 2 squared. Then 9 is 3 squared, 16, 25, 36. You should probably have this list handy somewhere. 49, 64. So in other words, write it down. Oops, I forgot one. 64, then 81, 100, ... Okay, there's an infinite number of perfect square factors. After 100, it would be 121, then 144, 169. That list should suffice. And we'll keep referring back to this to simplify radicals. Now, taking a look at a couple of examples of simplifying radicals. So when you're simplifying radicals, what that also implies is you're putting your radicals in simplest radical form. So unless you're taking, say, the square root of a perfect square, you don't want to just enter things into your calculator and get a decimal approximation. That's not simplifying, that's approximating. So on the first example, square root of 25, that should be something that you're familiar with, but I just want to point out when you take the square root of a perfect square, this is the square root of 25, or you could also say what number squared is equal to 25? It's exactly equal to 5, and just 5. Once you take the square root of a perfect square, 25 is a perfect square, it's 5 squared, that gets rid of the radical. Okay, so it's exactly 5, not the square root of 5. On the second example, square root of 20. 20 is actually not a perfect square. If you try to take the square root of 20 on your calculator, it'll give you about 4 point something. And I don't want to round this to the nearest tenth, hundredth, or anything. I want to simplify the radical. So what I want to do is look for perfect square factors of 20. And if this number is not a perfect square, which it is not, there should be only one perfect square factor. It shouldn't break up into something like 4 times 9. Where both are perfect squares, 4 and 9, because then that just means the original number or radicand is a perfect square. But 20 does contain a perfect square factor, 4. 4 goes into 20 5 times. So I could rewrite the expression as the square root of 4 times 5. 4 times 5 is 20. These are equivalent radical expressions. But then I would break that up into two radicals, the square root of 4 and the square root of 5. Okay, maybe you skip this step in the middle and then just go to the square root of 4 times the square root of 5. Really, I should write the square root of 4 first because this is the perfect square. And then once you take the square root of 4, the square root of 4 is 2. So square root of 4 can be simplified. It's 2. It comes before the radical. The square root of 5 cannot be simplified. The only factors of 5 are 5 and 1. I crossed out 1 because you can take the square root of 1 all day. Square root of 1 is just 1, and then you multiply it by whatever you started with. You get the exact same thing. So 2 square root 5, or 2 radical 5, you could also say. You just say 2 root 5. This is what's known as simplest radical form. The 2 should be written first because it comes outside the radical, and then the square root of 5 should be written second. It's kind of like if you have x times 2, you should know to write it as 2x. So 2 times the square root of 5, this is simplest radical form. Or, in other words, it's the exact value. Again, about 4 point, whatever the square root of 20 is. Let me check on my calculator real quick. But if I took the square root of 20 on my calculator, it would be about 4.5 if you round it to the nearest tenth. That's just approximating. Here, we're putting it in simplest radical form. The directions might just say to simplify.